हेलो। अपने प्रोफेसर साहब जिनका नाम एडा बग हंटर है, वो अपनी एक स्टूडेंट है, उसका नाम है नीना डिबग राव। अब ये स्टूडेंट अपने प्रोफेसर के पास जाती है और पूछती है कि मुझे एक एआई बेस्ड वॉइस एप्लीकेशन बनानी है। कैन यू प्रोवाइड अ लेक्चर हाउ टू बिल्ड वॉइस बेस्ड एआई एप्लीकेशन? उसके फंडामेंटल्स क्या हैं, उसमें कौन कौन सा टेक स्टैक यूज कर सकते हैं, कौन कौन से मॉडल्स लगेंगे। तो ये लेक्चर होने वाला है थोड़ी देर में, एंड इफ यू वांट टू कंटिन्यू प्लीज स्टे इन दिस वीडियो टिल द एंड। सो लेट्स स्टार्ट। जब भी कोई वॉइस बेस्ड एप्लीकेशन बनानी है, विच मीन्स एन LLM बेस्ड, मीन्स it will understand the language, and there can be an agentic way of building the application where different agents will interact and bring the output. But right now you might have seen applications which are built using the LLM, but the input is text and output is also text. But how to turn this agent into a voice based agent? Which means the input can be voice, output should also be a voice, right? So there are certain frameworks which help you to build this application, but before talking about that particular framework and revealing the name of those frameworks, first understand the fundamentals and how those will work. Now, before we deep dive in what are the different components, consider why there's a huge surge of applications which are based on voice. So there can be a different languages, right, for a voice, and people can talk and then they should get an answer. It's easier than typing your query and getting the answer, right? Also, the third factor of why this particular type of applications are increasing and there is a higher demand now, or the innovations which is happening, is because when you start listening the answer, and if you think it is not in a proper direction, you can again tell the model, you can revise your query, right, and then your answer will come. So it's a real time. Now, using this tech stack, you can build many such applications for solving your, let's say, customer calls, right? Your basic queries can be directly solved by the LLMs if you provide the proper context and the RAG-based techniques that we can use for providing the actual context. So let's talk what are the main components. Given speech is the input and LLMs are based on text, right? So you need some model for converting your speech to text, which is called STT models. And same as at the output side, LLM will spit text, but your output should be speech, right? So you need some model which can translate your text into the speech, which is generally called TTS models. So three components. One is STT models and LLM, and third is TTS models. But the application will not be completed here. It need to have another component which is called voice activity detection, VAD. Means in real world voice based application, what can happen? Some user might say a query, and then while listening the response, it can again interact with the model with a different query or some clarification query, or revising its query, right? There can be n number of things can happen. So this voice activity detection, which is nothing but a classifier, basically which detect all the incoming voices and identify whether this voice should go into the this particular input, right? Because in a real world there can be many people are talking around, and you identify only there is a one particular track which you want to listen as an input. So this WED system allow the whole application to detect the voices and then which one to feed in the input. So we have the four systems right here, and these four systems are very critical for building your application, but this will not complete if you don't talk about LLM and this agentic part, like how you will be solving this particular part of the problem. Here, let's call it A. We need a better model which can reason, right? So some reasoning models that we should be using here. And what reasoning model do basically, they help us to understand the context, break it down into multiple sub queries, and try to think, or basically a subtask, and try to think a solution for each subtask and then build a final solution. Like we have many reasoning models now, and they take some time. There is a higher latency, but still if you use reasoning models, it is able to solve some harder problems. But if you go with normal models, there are chances it will give the response based on what is defined in that particular model while training, or if you want to use some proprietary knowledge or let's say latest information, then you need to have the RAG system. RAG is basically retrieval augmented generation, which is helpful for providing the context, right? And this does not need to be a one single model, a simple query to the LLM, but it can be agent, right? And this agent can be interacting with multiple agents or different types of architecture, right? So many innovations you can do here. So now Nina Debug Rao is amazed by this type of explanation and understanding the fundamentals and components which are useful when thinking of building any voice based AI applications. Now these are the different parts, right? But to work and create an application in a faster way, it's easy to use some framework. So Professor Ada Bug Hunter is familiar with one framework which is increasing day by day, and it is more comprehensive to build a complex agentic application, and it provides some functionality where the input can be given through some phone, right? There can be like some adapters which will take different types of input, combine it here, provide it to the LLM, basically not just one LLM but the agentic application it can build, different types of agent which are interacting, and then providing the output, basically a TTS model. One more thing we need to notice here, we should be using the streaming, right? The LLM, the agentic applications can't be built which think everything about the input, take the final out response and return. That will have the higher latency. But if you build through streaming, basically streaming will help you for real-time conversation, and your application would look like someone is replying based on their query, and if you interrupt, it will redefine the responses. And this streaming can be part of the framework and how we build it. And if you know about the protocols, right, about how the streaming type of application can be built, which is basically through WebSockets, means you need to have a duplex connection and continuous connection between your source and the target. Their connection will continue till this particular session is not out. So taking the input in a different form, using the TTS and STT at the input, WAD system, your agent application, these are the different components, right, which you have to think and plan how you organize all this information, different components, so that your application perform better. And if you are thinking of some framework, here is the recommendation of LiveKit. This particular framework help you in defining all these things in a very clear way, and your application will look better, your code management can be happen in a proper way. So I guess this is helpful for understanding how AI based application works. Now the Professor Bug Hunter want to know what you are building. He will be amazed to see different types of application, and you can put a comment what that particular application that you are thinking. Just put the idea and he is able to help you in ideation and setting up the proper architecture. Now this is up to you and our beloved student Nina Debug Rao, what they are building. Rao, please put your comments first, and then I hope all the viewers will also put what they are building and what are their queries. Let's meet in next lecture. Thank you.